The site survey provides valuable information on existing LAN communications and computer equipment to see if any upgrades will be needed to establish the service. The survey should evaluate the current software environment, including operating system, communications, Windows or Mac interfaces, current Internet programs, and client preferences for desired software to be installed. The site survey assesses the cable plant for potential implementation of trunk line and/or LAN communications and reviews existing or possible new carrier sources. When the site survey analysis is complete, the next step is to develop the requirement specifications. Using the information gathered in the site survey, the program coordinator should develop requirement specifications that consider the major factors and constraints affecting the site-specific Internet access program as shown here. The plan will need to optimize the user requirements within budgetary constraints. It certainly won't do any good to bust the budget. If there are known budgetary constraints, one can either design to fit and/or phase the program. By phasing the program, the coordinator can lay a foundation for the future, even if not all the capabilities will be installed initially. The coordinator will need to determine transmission speed requirements by understanding how the clients will access the network. In the language of telecommunications, bandwidth, that is, the transmission speed of communications, is the currency. By optimizing the utilization or providing an incremental upgrade plan, the coordinator can effectively use the Internet service. Many times I have had clients ask, well, how much does it cost to get on? And I answer, well, let's start first with what you want to use it for. Large organizations may wish to manage and control their own wide area network service instead of sharing access through a mid-level provider. Most smaller organizations will simply use an existing service. One of the most important considerations is the integration of the new service with existing systems. One of the politically viable and lower cost approaches is to consider a migration strategy that preserves the existing enterprise investment in information technology while evolving to more modern desktops and servers that will provide the emerging functionality. If a server is to be implemented, then client-server software functionality needs to be considered as well. Information presentation strategies for web access are very important for those organizations wishing to establish a presence on the Internet. The website needs to grab the attention of the cyberspace cruiser and should not take very long to download. Linkages need to be well defined. Content should be layered so users primarily see items of interest as they browse the site. Security is very important for the protection of IT technology and the privacy of all user files. Hackers are definitely part of the Internet culture. Strategies for firewall implementation, virus protection, and user authentication need to be defined as part of the plan. Large enterprises who have or are considering providing Internet service on existing private networks should seriously consider the staffing requirements for technical support, on-site service, and end-user training. Users selecting an Internet carrier should consider hotline service and training classes as part of the selection criteria. The requirements analysis is input to the network design and project plan, both of which provide the basis for technology selection. It should be noted that technology selection is a very dynamic process because the competition is fierce and the technology changes so rapidly. The information system strategy for a large enterprise needs to consider communications regulation and tariff changes, equipment price performance ratios, Internet carrier developments and services, and standards developments. All of these items need to be factored into a migration plan that considers the existing investment as well as user requirements in the following areas: communications dial-up speed, local area network topology and wide area network technology, premise equipment, desktop, servers, and wide area network interface. Software, desktop, the network, and internet application software. Rather than unleash an entire user community and spend lots of money up front, I recommend a phased approach. This provides the opportunity to gain experience and expand capability as user expertise grows and requirements dictate. One can start by selecting an initial subset of services and software to be supported. For example, the initial service could be email and web access. This phase is a good time to establish a basic home page for point-and-click access and presentation development. When users are trained on these applications and troubleshooting has stabilized, other services such as electronic bulletin boards, Turbo Gopher search programs, Waze programs, Internet Relay Chat, and other capabilities can be added. Rapid prototyping with a small group of users reduces the risk of system-wide pioneering. This trial period can be used to develop knowledge of Internet services and train a group of trainers who can then assist large-scope deployment. Rapid prototyping also provides the opportunity to adjust plans based on lessons learned and advances in technology that occurred during the prototype phase. In essence, rapid prototyping will provide a foundation for expansion with greater confidence. Deployment is full-scale implementation of Internet services for the entire organization. At this stage, design has been refined based on rapid prototyping and further understanding of requirements and available technology. The request for proposal and/or implementation plan should reflect the lessons learned and implementation criteria discussed earlier. In particular, it is important to provide for adequate end-user training and support. If you plan to have an accessible website server, the RFP and/or implementation plan should consider how end users will enter your site. The web page design should be attention-getting and quick to download with an easy-to-follow roadmap through resources that you wish the external user to browse. A firewall should be implemented on the server to protect in-house applications with appropriate management procedures for controlling the gateway through the firewall in both directions. Additional applications identifiable from the home page should be clearly defined and supported with a complete training program, including online help. To conclude, I would like to summarize some of the key points for enterprise-wide Internet service. Plan a sound migration strategy that will minimize disruption to existing operations and maximizes the usage of the existing investment in IS technology. Consider rapid prototyping and phased implementation to reduce risk and provide for a smoother, friendlier transition to full Internet service usage. Plan for future growth. Usage of the network will expand as more users come online and the demand for a broader range of services is realized. Retrofitting is expensive. It is better to go to the trouble in the beginning to lay the foundation for expansion. Consider buying one level down from the top-of-the-line desktop computers. You can achieve excellent price performance results with systems that are a few months old. Be sure to implement a security strategy that protects your IS assets from hackers and viruses. Also be sure to provide for user-friendly access and training. And most of all, have fun cruising cyberspace and communicating around the world. Remember, communications is not the same as knowledge and information. Communications is merely a media for providing for information movement. This is best illustrated by the highway model. The highways connect cities and towns, but accomplish nothing by themselves. Accomplishment is achieved by the effectiveness of those who drive those highways. The same is true for electronic communications. We should have a definite purpose for any networking project and a well-defined task to accomplish before we bring this new technology to our workplace or home address. Otherwise, we're just flooding the world with more useless information. It is important for us to become responsible communicators, collaborators, and partners in the effective use of the global information superhighway. Let us use this technology for enhancing our societies and improving world relations as we march ahead into the 21st century. Thank you.
Thank you, Mr. Smith. Let us begin our second question and answer session now. We have a phone call from Coahuila, the Universidad Iberoamericana, Campus La Laguna, Torreón. Welcome. Your question, please.
Can you use other operating systems such as AIX of IBM or Unix or OS400 for the AS400 computer, the IBM computer, and will these provide a better performance when compared to Windows or Macintosh?
All right. What kinds of computers work with this?
Basically, most of the major computer vendors, such as IBM and Digital Equipment Corporation and Hewlett-Packard, all provide Internet support through their operating systems. And of course, the faster the machine, the two ways that you can introduce Internet performance is through machine speed or communication speed. So even though you may have a large processor, if you don't have the bandwidth or the capability of the communication system to support it, it won't improve the performance dramatically. The AS400 systems do support Internet. The Unix, of course, is an Internet implementation. In fact, the Unix operating system is the operating system of choice for web client servers. They typically are installed on Digital Alpha workstations, Sun SPARC stations, and other Unix-based platforms. And of course, for those users who are on a Unix-based local area network, can then use the Unix support for TCP/IP as a gateway to the Internet.
We have a call from Argentina, the Universidad Nacional de CORDOBA. Welcome. Your question, please.
Thank you. My question is, do you think that there is an integration of telecommunications between the cable and phone system that could be incorporated at the home user level with the Internet?
All right. Either of you want to tackle that?
Well, actually, that is being worked on currently between the cable companies and the phone companies. It's not quite sure at this point how the shakeout will occur and whether they will fight with each other or they will work with each other. I know, for example, that Sprint Business has invested significant amount of money in Cox Cable, for example, in delivering a joint package to the home. However, it is delivered to the home via the cable company. The offering there is broadband communication support, which means that it'll work very much like your television, and therefore, it'll be graphics rich. As they install fiber optic cabling and deliver that into neighborhoods for use by homes, then the phone companies also have that broadband capability as well. So it'll be very interesting over the next couple of years whether the phone companies and the cable companies work together or wind up suing each other.
We have a fax now from Itac in Sao Paulo, Brazil, and the question is, how could the World Wide Web be used in a library to improve library bibliographic searches?
There are a couple of ways in which it can be used. First of all, the Internet contains a lot of bibliographic resources, and the web can be used as a way to put a friendly face on it, a friendly front end. But in addition to that, in a library, if you have your card catalog already on disk, using something called a CGI, a program that will interface between the web and your existing database, you can make the web be the front end to your card catalog as well. One of my colleagues is a librarian, and she's working on a web page right now in which a series of pages will guide the user through the process of figuring out what resources they need to use. And through a series of questions, we'll lead them to exactly the right resources, and then by clicking on an anchor, they'll go to the thing that they need to look up.
I'd just like to add one comment. I gave a presentation about a year ago at the American Library Association talking about library automation and internet applications, we had a very interesting response when I made the comment that many folks tell librarians that they need to have internet access to survive in the 21st century. And my comment was that I felt that the internet needed librarians to help organize and catalog the resources that are available out there.
Mm-hmm. As a writer, I am especially grateful for the bibliographic uses of the internet. Those times when you had to run to the library to check the year of publication of a book or something like that, now can all be done without moving an inch. It's wonderful. We have a call now from Panama, from the Universidad Tecnológica de Panama. Welcome. Your question, please.
Buenas. Hello. What kind of security does Internet offer as regards essential or confidential information?
Security. Jeff?
Well, I guess I'd like to start by saying that the Internet itself is inherently an open system, and the Internet does not offer security. Security is achieved at the enterprise level as each individual enterprise determines what assets it wants to protect or which systems it wants to restrict access to. Once the enterprise has established a security plan for its information technology assets, then what can be implemented is, depending on the level of requirement to protect that information, you can implement a firewall strategy to protect the access. If you're transmitting data such as credit card information, that data can be encrypted through commercial-grade encryption devices that are available to run on Internet systems. So you could protect confidentiality by encrypting data, by restricting access. But the way to do this, of course, initially is within your own organization to implement a security strategy. So as such, the Internet, visualize that as a highway, and as such, there are no security offerings itself.
Okay, we have a call from DF, from the Comisión Federal de Electricidad, Auditorio Atoyac. Welcome. Your question, please.
Auditorio Atoyac.
Gracias.
What basic equipment requirements do you need to get online to the World Wide Web? Thank you.
Basic equipment needs to reach the World Wide Web.
Well, your basic equipment needs for the World Wide Web, the minimum requirement is something in the range of PC 486, an Intel chip 486 level or above. It's not that 386s can't exercise themselves on the web, but they are slow, and when you get into the graphics type environment, they don't process very well. Also, the minimum requirement is in the range of 8 megabytes of RAM, so that rapid access memory, so that you have enough memory to download the images and the files that you need directly into your machine. And of course, having enough disk space if you want to start downloading articles and books as well. So somewhere in the range of a half a gigabyte hard drive is the minimum requirement to interact in that way in terms of taking information from the network. Communications-wise, to participate in the web really doesn't make much sense until you get to the range of 14.4 kilobits per second. At 2400 baud, downloading a graphics image from the web to your computer really does take too long, and the delays involved with that don't make it very user-friendly. So you want to be thinking in terms of 14.4. I'd like to comment, though, that most computers made in the last year and a half ship pretty much standard with that configuration, 8 meg of RAM, a half a meg hard drive, and that modem. And roughly, a system at that level, which is just a dial back from the state-of-the-art, runs you about $1,500 US dollars, and you have what you need to access the web.
Bernie, have you run into any particular problems people have had accessing the web?
The biggest problem people seem to have is if you're dialing into a system, you need to set up either a SLIP account or a PPP account, and that is not yet transparent. Every system seems to be a little different, and where people have some trouble is setting the control panels exactly right. But once that's in place, it doesn't change, and then wherever you are, you can act as if you are directly on the Internet.
So you may need a local guru for a few of the initial.
There's no maybe about it.
Well, there's no maybe, but I would comment that with the new Windows 95 operating system, they are simplifying how that's done. But the key issue, as Dr. Dodge said, is that you do have to get over a little hurdle, and this can be difficult in some countries, to be able to access a website that has enough technical support to at least help you set up your serial line interface protocol hookup or your PPP hookup. I should mention that, for example, there's a list of websites in Mexico on page 95, and that's just an example. And one of the things that you could do in each one of these countries is locate those sites, and that's probably where the tech support would be to provide the information you need.
We have a call now from Tamaulipas, the Universidad Autónoma de Tamaulipas. Welcome. Your question, please.
Mr. Smith, how rapidly or how quickly will we be able to talk with voice and sound using talk, write, or sharp within the Internet? Thank you.
Okay.
I'm not sure I quite understood that question, but I think the question was working with sound and video as well as data at the desktop level. The Internet now does support packetized video, which does allow for some rudimentary compressed video technology to be delivered to the desktop. Of course, most machines now come equipped with sound cards, and when you access through the web, sound information can be delivered as well. For example, if you would like to hear a speech or see a speech by Dr. Martin Luther King, when you access that, you will see the photographs, and you will see the scene that at the Washington Monument where he delivered the speech, and you would also hear it. So those services are available, and again requires a system with a sound card, a 14.4 modem, and the web browser software to support that.
Okay. We have a call from Sinaloa, from the Colegio de Bachilleros Estado de Sinaloa in Culiacan. Welcome. Your question.
We're an educational institution that is developing the highest standards of excellence, and we're interested in looking at alternatives to multimedia use and Internet, given that the communication lines are relatively slow.
All right.
Well, one option, while you wait for your telecommunications system infrastructure to improve, a lot of what we talked about here in terms of the World Wide Web can be done within a single facility. So if you wanted to distribute materials and to store and deliver lectures and other materials asynchronously, then you can set up a web server in a networked computer environment just within a single building or within a single campus, and that I think is good practice for the future when your phone system catches up with you.
I'd also like to mention that if you follow Dr. Dodge's suggestion of possibly bringing up a local area network, say within your campus environment to support website use, you'll accomplish a couple of other things in the process. You will train a group of people who will be proficient on the web. You'll have also trained a group of people that can develop web materials. Then when you expand it into a wide area network context, you will have a baseline of support for your users as you add them on. And of course, you're exactly correct when you say that the weak link in the Internet chain can be the physical communications. So as I mentioned earlier, it's going to require developments in the fiber optics and global cellular technologies and things of that nature to have really seamless wide area network implementation. So if you start with what Dr. Dodge talked about, then you'll have baselined the system, trained your group, and then as you introduce wide area network communications to your other users, you'll be able to do that, and you'll have a basis for that support, and you'll have robust materials that will drive that access. In other words, if they want to reach your home page, they want to belong in your environment, that will greatly facilitate any wide area network implementation.
We have a call from UNAM, from the Facultad de Medicina Veterinaria y Zootecnia in Mexico, DF. Welcome. Your question, please.
Morning. I have a question. What have we seen as regards email use and its progress regarding consulting services or advice given for long-distance education?
Okay. Dr. Dodge?
Well, there's a variety of things at a variety of levels. We've seen even down to the level of school children, setting up relationships with experts in the field where a 6th grade student can ask questions of a university level biologist and bring that biologist essentially into the classroom. I think if you look at news groups on the World Wide Web, on the internet, you can see in essence a form of an invisible college that is worldwide in that everyone can be an expert and anyone can ask a question, and we're building a learning community that is based on email that cuts across all boundaries, both national and subject matter boundaries.
Right. I'd like to add also that there's a form of interactive email, if you will, known as the Internet Relay Chat that allows an interaction. So you can have a group of collaborative learning or a group of children interested in specific topics, and you can actually set up an interactive chat session and sort of ask questions of the professor in an online way, and that professor or industry expert can respond accordingly. And I will say also that we use electronic mail in that fashion to communicate and provide support to our customers on systems that we install. We use the internet in that way to provide technical support when in a more timely manner to solve most of the basic problems without having to dispatch someone to that site.
We have a call now from the Centro in OCOTLAN, Jalisco. Welcome. Your question, please.
Gracias.
How can we control confidential information when on the internet? Is there any possibility of piracy, and how could we incorporate or use this in a quick fashion in a relatively short period of time and in low cost?
All right.
Well, that's a lot.
Piracy, security.
Piracy, security, and cost. First of all, when you implement your security strategy, you want to balance your threat, what you perceive threat is, with the cost of implementation. So what you're looking for, again, when you protect confidential information, the best way to protect it is to not make it available. But if you're going to make it available to some users, then you have to provide for authenticated access to that particular type of information. There's a standard, I believe it's ISO 95 for the authentication of computer data online that can be implemented there. The cost, quite frankly, is going to depend on the status of your facilities, how your systems are networked, and